Okay, today we're going to start talking about lesson 8.2.1, which is introducing imaginary numbers. And yes, imaginary numbers are a real thing. And if you're wondering where imaginary numbers are coming from, let's think about, well, what if we had to solve something like this? And we've seen this a lot. X squared plus 4x plus 5 equals 0. I know some of you would think, oh, I can box and diamond this because 5 becomes 1 and 4. But I can't add, 5 becomes 1 times 5, but I can't add 1 times 5 to make a positive 4. If my signs were a little bit different, I could factor this, but because they are all positive, I cannot factor this. So I have to use the quadratic formula. And this is something that you guys have to know, so make sure you write this down if you don't already know it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And remember, whatever number is in front is the a value. So a equals 1, my b equals 4, and c equals 5. If any of these were negative, then the negative would transfer up to those letters. So quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay. When I square 4, I get 16. When I multiply these together, I get negative 20. Of course, I get 2 on the bottom. When I subtract 16 minus 20, I get negative 4. And so far, what you guys know is you'd get to this point and you'd say, no real solution. And you would be correct, but what we're learning today is that all numbers aren't real. Some numbers are imaginary or complex. So this does actually have 2 solutions. We're going to figure out by the end of this lesson how to actually solve this and find the 2 solutions. Okay, but we're not quite there yet. So let's talk about the definition of I. We'll get back to those boards in a little bit. Okay, and the definition of I is exactly coming from this problem right here. When you have a negative inside the square root, you guys feel like, hey, I can't take the square root of a negative number. And so far, you've been right. But the definition of I comes from, at some point in time, somebody said, well, there has to be a solution here. And so they made a definition of I to just be the square root of a negative number. Okay, so this definition is really important. Anytime you see a negative in the square root, it becomes I. So let's see what that looks like when we do some practice problems. Okay, if this just says to simplify, again, previously you guys would just say, well, I can't simplify this. I can't have a negative inside the square root. Okay, but now we know anytime we see a negative inside the square root, Mom gets mad, no negativity in the house. She kicks them out, and it becomes your imaginary friend. Okay, we do know the square root of 4. The square root of 4 is 2, and our imaginary friend is with us. So the square root of negative 4 simplifies to be 2i. Okay, same thing for square root of negative 25. We know the square root of 25. The square root of 25 is 5, but because there's a square root of a negative number, Mom kicks it out, becomes your imaginary friend, 5i. Just like we don't say x2, we wouldn't say i2. Instead, we say 2i or 2x. Same thing here. Okay, so this one, oh, square root of 100 is 10. There's a negative there, so it's 10i. This one's a little bit different because we don't know the square root of 7, but the negative still gets kicked out. So we can write I times the square root of 7. You can write it the square root of 7 times I. The problem is you can never quite tell if the I is inside or outside the square root symbol. So this is the best way to write it. Okay, same thing down here. I can't simplify the square root of 53, but I do know that the negative cannot stay inside the square root, so I have to kick it out. And I have I times the square root of 53 as my simplified answer. Okay. Now we're going to keep going. We're going to talk about operations with I, math operations, adding, subtracting, multiplying, and eventually dividing. We're not going to get to dividing today. We're going to treat I like any other variable that you know for the most part. So if this was 2x plus 2x, you'd know that it was 4x. Same thing here. This is just 4i. Okay, 5i minus 3i. Those are like terms, so we just call that 2i. Okay, don't get confused or tricked here. Even though there's parentheses around these two complex numbers, it's still just addition. So we're just adding like terms. So 3 plus 3 is alike, and 2 plus negative 2 is alike. 2i plus negative 2i, that actually becomes 0i. So this one just simplifies to 6. Okay, this one again, even though there's parentheses, it's asking us to add. So 5 plus a negative 6 is negative 1, and 4 plus 2 is 6i. Okay, now this is called standard form of a complex number. We also call it a plus bi form. All that means is we're putting the real part first, and we're putting the imaginary part second. So the real part plus or minus the imaginary. Okay, last one. Again, we're not multiplying just because we see parentheses. We're actually subtracting here. So all we're doing is subtracting like terms. 7 minus 6 is 1. And 5 minus negative 2 is a positive 7i. Okay, so you guys can add and subtract, no problem with operations of I. Okay, a few more operations of I. Like I said, we're not doing the division part today, but is multiplication. Okay, so again, we're treating it just like if this was 2x times 3x. Okay, 2x times 3x would be 6x squared, but we have an I. Okay, now we need to go back to our definition board because we need to understand what I squared means. Okay, if I multiply both sides by I, okay, what's the definition of I? Well, it's the square root of negative 1. So on the right, I get I squared. On the left, I get the square root of negative 1 times the square root of negative 1. In other words, the square root of negative 1 squared. But what happens when I square a square root? That stuff disappears. So negative 1 is equal to I squared. So this is the second part of the definition of I that's really important that you understand. Okay? So what that means is we can't just leave the I squared here. Okay? Instead, anytime you see I squared, you just have to know that really means negative 1. So this problem really says 6 times negative 1. In other words, the answer to 2i times 3i is negative 6. Okay? Here, next, I'm going to multiply. Negative 4i times 5i becomes negative 20i squared. But again, we have to remember, anytime we see this the I squared, we should be thinking negative 1. So we have to change that sign. Okay, positive 20. Okay, last one that looks kind of like this with no adding or subtracting. We know, of course, we have to do the exponents first. So if I square this, I get 4i squared. And then I have negative 5i. And I have to multiply those together. Before I multiply those together, let's take care of the I squared. Again, I squared just means negative 1. So this is really 4 times negative 1, or negative 4 times negative 5i. Negative times a negative is a positive 20i. Okay? Anytime you're doing operations with imaginary numbers, you're not done until you're down to just an I to the first power. Here we didn't have any i's, that's great. Here we had I squared, but I can't leave it as I squared, and I can't multiply it out and have it I cubed. I have to keep going until I'm down to just an I with a degree of 1. Okay, these now kind of look like what we did here, only these had addition or subtraction signs. This does not, which means they want us to multiply. Okay, and again, you're going to treat this just like you would if it were x's. So I'm going to make a generic rectangle. I'm going to put 3 plus 2i up top. I'm going to put 3 minus 2i along the side. And I'm just going to multiply the parts. I get 9, 6i. That becomes negative 6i. And this becomes negative 4i squared. Okay? So the 6i and the negative 6i make a 0 pair. So those are done. So I really have 9. And then remember, this I squared is really a negative 1. So it changes it. Okay? So I really have 9 and a positive 4, which is 13. So that's an interesting thing we're going to look at later this week. sometimes when you multiply two complex or imaginary numbers together, you do get a real number. Multiply two complex, we got a real. Multiply two complex, we got a real. This time, we multiplied and we still had imaginary. Okay, let's see what's going to happen here. Same strategy we learned on the left, or we used on the left. You guys have known this strategy for a long time. Generic rectangle, 5 plus 4i, negative 6, positive 2i. Okay, we're just doing multiplication. So we get negative 30, negative 24i, positive 10i, and 8i squared. Okay, now this time I don't get a zero pair, but I do have to remember to simplify I squared. Okay, so that really becomes negative 30 minus 8. Let's see, I'm running out of space here, which is negative 38. And then here I have 10i minus 24i, which is negative 14i. And remember, I want to write it in standard form. I'm going to put the real part first, the part that doesn't have the I, and the imaginary part second. Okay? There's your introduction to imaginary numbers.